So welcome back, dear students. So we'll continue the hydraulic circuit elements. So today we are going to see about the different types of valves and conditioning elements. So these are the different types of flow control valves. First we will see the flow control valves, orifice valve, throttle valve, flow control valve, different three types, and the flow divider. Okay. So orifice valve, orifice, is a small opening in a pipeline, right? Orifice meter you have seen in the lab. So that is represented like this. There is a line, fluid line, and two arrows, so that there is to show there is an orifice valve. Then throttle valve, there are two types of throttle valve, fixed and variable. Variable is always shown with an arrow here, like this. And fixed throttle valve is like this. So throttle valve is working, the flow will be depending on the pressure difference across the valve. The pressure difference across the valve will decide the flow will take place or not. And throttle valve plus a check valve, a bypass line is provided here. So in one construction you can have this check valve plus check valve plus the throttle valve like this. Now coming to the flow control valves, there are three types: pressure compensated, pressure and temperature compensated, pressure and temperature compensated with a check valve. Okay, so if it is only pressure compensated flow control valve, so you can see this is your throttle valve. Okay, throttle valve, variable throttle valve, and this arrow, upward arrow, represents the pressure compensation. And if a line with a dot at the end, bottom, that represents the temperature. So pressure and temperature compensated flow control valve, throttle valve. Okay. Pressure and temperature flow control valve with a bypass check valve. So there is a check valve here, a bypass line, pressure, temperature, and the flow control valve, variable throttle valve. So that is in a single construction. I hope it is clear. Now coming to the flow divider, if you want to show the flow is divided from a line to two different lines, you have to show like this. A flow divider with valves is shown like this. A flow divider with two coupled motors. You know this simple, this horizontal line here with a narrow opening shows the coupling, right? So flow divider with two coupled motors. These are motors, a circle with arrow pointing towards the center, solid filled arrow. That is the motor, hydraulic motor, and these are the flow dividers. Okay. Now the second category of valves is check valve. That is the second category. Non-return valves, pilot operated check valves, solenoid operated check valve. All these will come under check valves. So could you tell me an example for a non-return valve? The foot valve used in a sump, where you are using um, a pump to lift water from a sump to overhead tank. So where at the sump at the bottom you use a non-return valve, right? So a non-return valve is usually represented like this: an arrow, a circle, and the fluid line. Okay, with or without closing spring. Then pilot operated check valve is represented like this. This opens in one direction only when set pressure is reached at pilot line. Okay, so this is also a single direction valve, but it is pilot operated. That means it opens that specified direction when the set pressure is reached in this pilot line. Fine. Then solenoid operated check valve allows flow in both direction. See, the this arrow represents the direction of flow is in both direction, and this one shows that flow will be allowing only in one direction. That means it is a non-return valve. This is symbol for non-return valve. So a solenoid operated check valve could be of two types, that is where the flow is in the two directions and flow is only in one direction. So if the flow is only in one direction, that means it is a non-return valve that is usually represented like this. So a pilot operated valve is placed and a solenoid. Fine. If it is in both direction, this solenoid and this double-sided line with arrows on both sides will be shown. Now coming to the third category of valves, pressure control valves. There are pressure release valves, pressure relief valves, pressure reducing valves, and pressure switches. First one is directly operated pressure relief valve. So it is usually in closed condition, normally closed. Okay, it is normally closed, open on actuation. When the pressure is reached that set pressure level, then it will be opening. Okay, when suppose in a storage tank or in a line, if the set pressure is reached, then only this valve will be opened, otherwise it will be in the closed condition. Then pilot operated pressure relief valve. This is again, you can see a pilot operation is shown, and this is a symbol for pilot operated pressure valve. So in addition to this, you can see another rectangle with a closely filled arrow here. Directly operated pressure reducing valve. So you can see the difference in the symbols. Normally in the open condition. So normally this will be in the open condition. You can see the difference here. So here this line, and here there is a dot. Okay, fine. So there is no pilot thing. So there is a difference in the symbol. This dot, normally it is in the open condition. It is open, this line. So there is a junction with a dot, means that is open, mixed. Fine. We have seen the joints. So pilot operated pressure reducing valve is the fourth one. So that is again, it is in the open condition. By default, it will be closed on actuation. Now the fifth one is pilot operated sequence valve with external signal input. So the valve switches and opens flow when set value of pressure is reached. That is represented like this. So there is an external signal input is there. So that's why this is shown. Then pressure switches. So in standard, you can see in electrical engineering also the symbol for switch is like this. A line with a circle, hollow circle at the end, and another inclined line with a circle. So when it is closed, that means there will be flow through it. So there is a pressure switch. Now coming to the last category of hydraulic circuit element is the conditioning elements: filter, cooler, heater, separator. These four come under this conditioning elements. So that is represented like this. A filter is represented with a diamond shape, I mean a square rotated 45-degree with dashed line joining the diagonals on a horizontal way. Then cooler is represented like this. Same way, there is a perpendicular line and two diagonals are there, and the horizontal diagonal is with arrows at both ends. Then heater, the arrows will be pointing towards the center. On the horizontal line, the arrows will be pointing towards the center. There are two arrows and pointing towards the center of the square. So inside arrow indicates heat is flowing into the system. Heater with liquid heating medium, if it is liquid heating medium, so there are two lines will be added, in which one is in the upward direction arrow, and the other one, the arrow will be pointing towards the downward direction. Then heater with gaseous heating medium, the arrow is not solid filled, it is not filled arrow, the arrow is open. We can't say it is open, it is not filled. So in the case of liquid, always the arrows will be filled with solid color, but in the case of gaseous compressible fluid, the arrows will not be solid filled. In separator, that is for removing water from air. So with manual drain is represented like this. Okay, with automatic drain will be represented like this. So anyhow, there is a square in this particular shape and a horizontal line just below the diagonal, halfway below the horizontal diagonal. And if there is no triangle inside, that means it is manual drain. If it is there is a triangle, that is automatic drain. Okay, so now almost all the important hydraulic circuit elements have been described in the among the three, I mean across the three lectures, I think, yeah, as three parts. Now if you have noted down all the symbols correctly and you have understood all these things correctly, you would be in a position to draw a hydraulic circuit of any fluid power system by combining whatever required for different elements. So be prepared for that. I'll be giving an assignment on that to draw the circuit diagram for a fluid power system. So in the next session, we will be discussing about the various hydraulic pumps, the different category of pumps, and the working, comparison, applications. So thank you for watching. Please subscribe to the channel to get the updates on videos on different subjects other than fluid mechanics. There are other playlists you can see: IC engine, renewable energy, then more will be uploaded soon. So you may share this to your with your friends also. So keep watching. Thank you. Have a good day.